Hello everyone. So now we have to find the volume of a region S, where S is a cone inside a sphere. Okay, so let's try to draw this first. So we have to use both cylindrical and spherical coordinates, and we will show that both the answers are same. Okay, so the given region here is cone, that is z square equal to x square plus y square, and we have a sphere, that is x square plus y square plus z square equal to 2az. Okay, so this gives us a hint that the center is not origin because there is a linear power of z. So we will try to make some adjustment that gives x square plus y square plus z square minus 2az equal to 0. Okay, so we reduce it to this and then we will try to make this as a complete square. So we will add a square on each side. So this also becomes a square. And finally, this reduces to x square plus y square plus z minus a square equal to a square. Alright, so we have a sphere whose center is on z axis, and then we will try to plot this down. So we will take our x, y and z axis, and obviously the sphere of radius a, center is at 0 0 a, and then we have a cone which is given by which is inside this we have an equation of a cone inside the sphere. Okay, that means we have something like this. All right, so this is our region and we want to find what is the volume of this region. So we need to check what will be the volume of this region now, and for that we are going to make use of spherical and cylindrical coordinates. So the first one I'll do by spherical coordinates. So we know that in this case x will be equal to rho cos theta sine phi, z is equal to rho y is equal to rho sine theta sine phi, z is equal to rho cos phi, the Jacobian is rho square sine phi because we are changing the variable, and then we have to fix the limit of each. Alright, so here what we are going to do here in this case, the radius, we have to be very cautious with the radius because our radius, if we see, if I take a radius like this, it is changing the length. As it moves along the circle, the length keeps changing. That means the radius is dependent on this circle or this curve. Okay, so in that case, first thing is, for radius we will take this equation back because the if we see at any point the strip will touch the z axis, the sphere, it will always touch the sphere. That means we will consider the equation of sphere, that is x square plus y square plus z square equal to 2az. And if I put my spherical coordinates in this, or if I try to check the spherical coordinates, so what I'm going to get is a square, so x square plus y square is uh, x square plus y square, so x square plus y square plus z square is going to be rho square is equal to 2a. Z we know it is rho cos phi, so we will take rho cos phi, so rho and rho cancel, and then we get rho is always 2a cos phi. Alright, so we can see that when the angle with respect to z axis is 0, the value is 2a, that is the diameter of this sphere. Okay, so at different angle the value will be different, hence our rho in this case, where 0 less than rho less than or equal to 2a cos phi. Alright, now next is we want to take a complete circle, and we will keep it at this point and we will rotate. So we know that the volume of this, in this case the angle, if we see, it is varying from 0 to pi by 4 because this equation of cone, if we try to see in the yz plane, suppose this is z, and then we have z square is equal to y square because x is 0. So the equation of the cone is z square equal to x square plus y square. So in the yz plane, this is going to be 0, x is going to be 0. That means z by y is 1, which is same as tan theta. That means this angle is going to be pi by 4. Alright, so this is pi by 4 and this is pi by 4. So this is pi by 4. Alright. So we take 0 less than phi less than pi by 4 and 0 less than theta less than 2 pi. Because the projection is complete circle, if we look, it's a complete circle we are going to consider, and a complete circle we are going to rotate from this angle to this angle. Alright. So now we will try to put the formula of volume. So we know that volume is triple integral dx, dy, dz, and because of change of variable, it will be rho square sine phi, the Jacobian. Then we have d theta, d phi, d rho, where theta is from 0 to 2 pi, phi is from 0 to pi by 4. And okay, so since rho is dependent on this phi, so we have to change the order in this case. So what we are going to do, this will be equal to triple integral rho square sine phi, so d theta, d rho, d phi. Alright, because the rho is dependent on this phi. Okay, so this will be from 0 to 2 pi theta, rho is from 0 to 2a cos phi, and phi is from 0 to pi by 4. Okay, so we evaluate it one by one. So this is 0 to pi by 4, 0 to 2a cos theta, and then rho square sine phi is constant, integration 0 to 2 pi d theta, d rho, d phi. Alright, so this integral is going to be, this integral is 2 pi, so I'll take it out, 2 pi, 0 to pi by 4, and then integrating with respect to rho, so sine is constant, so sine phi integral 0 to 2a cos theta, rho square d rho d phi. Alright, so this is going to be now equal to 2 pi integral 0 to pi by 4 sine phi, and this is rho cube by 3, limit are from 0 to 2a cos theta d phi. Alright, so applying upper limit minus lower limit and taking these 3 out, so that will be 2 by 3 pi integral 0 to pi by 4 sine phi, and then 2a cos phi cube d phi. Alright, so this becomes 8a cube. So I'll take 8a cube out. So this is 2 pi by 3 into 8a cube 0 to pi by 4 cos cube phi sine phi d phi. Alright. So but this integral we can solve separately. We know that integral of cos cube phi sine phi with respect to 0 to pi by 4, so d phi, so we can put cos phi equal to x, that would imply minus sine phi d phi is equal to dx, and we need to change the limit. So when phi goes to 0, that would imply x goes to 1, because cos 0 is 1, and when phi goes to pi by 4, that would imply x goes to cos pi by 4, that is 1 by root 2. Okay, so we are left with integral 1 to 1 by root 2 x cube dx. Okay, so this is equal to x raised to 4 by 4 1, so minus is already there, right? So minus 1 to 1 by root 2, so the upper limit minus lower limit, that is 1 by root 2 raised to 4 minus 1, so this is minus 1 by 4, 1 by 2 minus 1, 1 by 4 minus 1, so that is minus 1 by 4 into minus 3 by 4, or simply 3 by 16. Okay, so this integral is going to be 3 by 16, that I'm going to substitute here. So which is 16 a cube by 3 pi into 3 by 16. So cancelling 16, 16, 3, 3. We get the final answer is pi a cube. Okay, so this is with respect to spherical coordinate. In another video we have done with respect to cylindrical coordinates, so please refer that. Thank you.